Teacher Mercy here again with a very interesting topic on LCM and GCD. Now, the meaning of LCM is lowest common multiple, while GCD stands for greatest common divisor. Now, let's begin by talking about divisors. Now, divisors are numbers which can divide another number without leaving a remainder. For example, if we look at 18 and 12, we can be able to list the common divisors in these two numbers. For example, all the divisors in 18 are 1, 2, 3, 6, and 18. The divisors of 12 are 1, 2, 3, 6, and 12. Now, all these numbers can divide 18 without leaving a remainder. And same case with 12, all these numbers can divide 12 without leaving a remainder. And therefore, we call them divisors. Now, this brings us to greatest common divisor. Which is the greatest among them? Now you realize that it is number 6. Number 6. So the greatest common divisor of 18 and 12 is 6. On the other hand, the multiples of 12 and 18 are, we have 12, we have 24, 36, 48, 60, 72, and so on and so forth. Then the multiples of 18 are 18, 36, 54, 72, 72 plus 18, 90, and so on and so forth. So like they are endless. Now, we are looking at the multiples that are in both 12 and 18. They are common in both 12 and 18. So we have the common multiples are, we have 36, we have 72, and so on and so forth. There are so many. We can continue getting as many as possible, but we want to know which one is the least common multiple of the two numbers is the smallest common multiple, which is 36. So that is the difference between GCD and LCM. So in GCD, we look for those numbers which can be able to divide those numbers without leaving a remainder. Then we check for the greatest divisor. While in LCM, we list down all the multiples of the numbers. And then we look for the smallest multiple. And we pick that one as the least common multiple. So that is it. Now, we have several methods of finding LCM and GCD, and the most common one which we are going to look at is the factor table, which involves arranging your numbers in this manner. For example, if we are looking for the GCD of 18 and 12, then we shall have the two numbers in a table like this. 12 and 18. So the question is, find the GCD of 12 and 18. So we are going to look for prime factors that divide both numbers. For example, 2 can divide both 12 and 18. So we place 2 here, so that when it divides 12, we have 6 and 9. Next, we look for another prime factor which can divide both 6 and 9. So 2 can divide 6, but it cannot divide 9, so we cannot pick 2 for GCD. But we can pick 3, which divides both. So that divided by 3, this is going to be 2, and this is going to be 3. There is no other prime factor which can divide these two numbers. So we stop at that, and we say the GCD will be equal to 2 times 3, which is equal to 6. So that is the factor table. We can also use the factor table to find the LCM, like in this case. So for LCM, we shall have our numbers 12 and 18. So 2 divides both 12 and 18, so that we shall have 6 and 9. Then in this case, as long as that prime number can divide either of the numbers, we still use it again. So we shall take 2 again. So that 2 divides 6 and 9 remains. Then we go to the next, which is 3. It divides this 3 and 9. Then we have 3 again, which divides this 3, and this remains as 1. So the LCM of 12 and 18 will be equal to 2 squared multiplied by 3 squared. And this is going to give us 4 times 9, which is 36. The same value we got by listing down the factors. Therefore, this is the factor table method for finding GCD and LCM. Let us now find the greatest common divisor of 24, 60 and 96 and 108 using the factor method. So as we've learned, we arrange our numbers in columns like this. We have 24, we have 60, we have 96, and we have 108. Then we put them in columns like this. Now, because it is greatest common divisor we are looking for, we are going to use the divisors which divide all the numbers all together. So, looking at the first prime factor which can divide all these numbers, it is number 2. 24 divided by 2 is 12. 60 divided by 2 is 30. 96 divided by 2 is 48. 108 divided by 2 is 52. Next, another prime factor which can divide all these numbers. I think you can see all of them are divisible by 2 again. So we repeat: 2 by 2, 6, by 2, 5, by 2, 24, by 2, 26. Let's go to the next number. Can we get any prime factor which can divide the remaining numbers? No, we cannot. Because looking at 5, it cannot divide. Actually, it is not even, so we cannot talk of number 2, we cannot talk of 3, and so on and so forth. And even if we say 5 itself, it cannot divide all these other numbers. Therefore, this question ends there, and we come here and say our greatest common divisor is going to be equal to the GCD will be equal to these 2 times 2, which gives us 4. Now, I want us to use the same factor table to find the lowest common multiple of these numbers. So, find the LCM of the LCM of 24, 60, 90 and 108 using the factor table. So we are going again to form a table similar to the one we had formed for the GCD. So we shall have 24, 60, 96 and 108, and draw lines, place them in columns like that. Now the first number which can divide, actually the least common divisor is 2. So 2, we shall have 12, 30, 48, 52. Then, in the case of LCM, we don't choose a divisor that divises all the numbers. But as long as a divisor can divide any of those numbers, then we use it until it is exhausted. So we go to 2 again. This will be 6, this will be 15, this will be 24, this will be 26. Now we go to 2 again. We have numbers here which are divisible by 2, 3. Now this one cannot divide 2, so it remains like that. 24 by 2 is 12, 26 by 2 is 13. We continue. 2 again can divide this 12, so these ones which cannot divide remain as they are. By 2, 6 by 2 cannot divide, it remains like that. Then we go to the next 2 again. 3, 5, 3, 13. Now from there we go to 3. 3 is the next prime factor which can divide all these numbers. So this will be 1, 5 remains, 1, then 13. Then we go to the next is 5. Because of 1, 1, 1, 13. Then finally we have 13 itself, so that it will be 1, 1, 1, 1. So our LCM is going to be equal to these 2, how many times? 1, 2, 3, 4, 5. 2 power 5 multiplied by 3 multiplied by 5 multiplied by 13. Now let's see from the calculator what that is going to give us. So 2 power 5 multiplied by 3 times 5 times 13, which gives us 6240. So our lowest common multiple here is 6240. That is our LCM for those 4 numbers. So that is how the factor method works. I hope those 2 examples have given you an idea of how to do it. Let's now move on to the next method, which we call prime factorization. Let us look at how we can be able to find GCD and LCM using prime factorization. And we answer this question. Find the GCD of 144, 72 and 252. Now here we shall first of all find the factors of 144, for example. 144, it can be divided by 2 to give you 72, by 2 to give 36, 2 again to give 18, 2 again to give 9, then 9, 3 because of 3. Those are the factors of 144. Let's go to 72. The factors are by 2, 36, by 2, 18, by 2, 9, then by 3, 3. Then 252, we shall have by 2, 126, by 2, 63, by 2 cannot go but 3 can because of 21, then 3 again because of 7, then 7 because of 1. So we shall now write down these prime factors in terms of their powers. For example, now we are going to express our factors in terms of in power form. So for example, in 144, this is going to be, okay, let me write it like this. 144 will be equal to 2, 1, 2, 3, 4 to power 4 times 3 to power 2. Then 72 is equal to 2 to power 3 times 3 to power 2. Then finally 252 is equal to 2 power 2 times 3 power 2 times 7. So you notice that in all these factors we have 3 to power 2 in all cases. We have 3 to power 2 here. We have 3 to power 2 again, 3 to power 2. Then we also have 2 to power 2 in all cases. Because this one being 2 to power 4 can be 2 squared times 2 squared. This one can be rewritten as 2 squared times 2 squared. So we just pick one. Then this one we can write it as 2 squared times this one are 2. So that we pick the squared one, and here we pick the squared one. So our GCD is going to be equal to the common factors in the three numbers, which are 2 power 2 times 3 power 2, which is going to give us 9 times 4, which is 36. Yeah, so now the factors of 144 will be written as 2 power 4 times 3 power 2, according to what we had found out. While the factors of 72 will be equal to 2 power 3 times 3 power 2. And the factors of 252 will be equal to 2 power 2 times 3 power 2 times 7. So I want us to rewrite this so that we have those factors which are appearing in all the three numbers. For example, if we can subdivide this to be 2 power 2 times 2 power 2 times 3 power 2, we will not have changed anything. We will not have changed anything. It is the same value as this. But there's a reason as to why we need to do that. Then this one, we can rewrite it to 2 power 2 times 2 power 2, then times 3 power 2. And this last one, we write it in terms of 2 power 2 times 3 power 2 times 7. So we are going to pick the common factors in all the three numbers, which are 2 power 2 and 3 squared, 2 squared and 3 squared, 2 squared and 3 squared. So all those numbers which are common in both the three numbers are our GCD. So our GCD will be equal to 2 squared multiplied by 3 squared, which is equals to 36. Same manner, let's get the LCM of these numbers. 1008, 1080, and then 588. So, factorization, that method I've just shown you is the same one we are going to use to get the factors, and the factors will be as follows. And remember, in LCM, we consider each prime factor as long as it can divide one of the numbers present in that in the list. Then we use it in order to be able to get the factors. So the factors for this particular question are 1008 is 2 power 4 multiplied by 3 power 2 times 7. 1080, the factors are 2 power 3 multiplied by 3 power 3 multiplied by 5. And the factors of 588 are 2 power 2 multiplied by 3 multiplied by 7 power 2. Now, what we do in this case, we are going to pick those numbers with the highest value. For example, looking at 2 power 4, 3 power 2, and 7, 2 power 4 has the highest value. Then looking at this 2 power 3, that is 8. 3 power 3 is 27, so this one has the highest value. And finally here 7 squared has the highest value. So our LCM will be equal to the product of the three highest values in our three numbers. So 2 power 4 multiplied by 3 power 2 multiplied by 7 power 2. And our answer is, from the calculator, it gives us 105,840. 105,840 as our answer. Let us have a look at a mixed problem involving both LCM and GCD. And a good example is the one before the example, it is important to note something about the relationship between LCM and GCD, in that if the LCM of two numbers x and y is L, if LCM of x and y equals to L, and the GCD of x and y is equals to G, then xy is equals to LG. Example. If the LCM of k and 32 is 96, if LCM of k and 32 is 96, and the GCD of k and 32 is 8, and their GCD is 8, find k. So what you do in this case, you just replace the values here. The two numbers are k times 32, and we know it should be equal to the LCM times the GCD. So 96 times 8. So divide by 32, divide by 32. Our k will be equal to, these two will go, and our k will be equal to 24. So that's how you work out such a problem. Now, the next concept we are going to look at is a situation whereby the LCM of three numbers is given and also their GCD. How do we solve for the unknown number? So, if the LCM of three numbers x, y, and z is L, if LCM of x, y, and z is equals to L, and their GCD is G, and their GCD is equals to G, we will have the following situation. If x and y are known, then the least possible value of z such that z times this. So if x and y are known, let's first deal with that. If x and y are known, then z multiplied by the LCM of x and y will be equal to LCM times greatest common divisor. So if the numbers we are dealing with are three of them and two of them are known, then the formula will be z times the LCM of the two numbers which are known should be equal to the LCM times the GCD. Now let's look at an example. If the LCM of 16, 24 and V is 336, LCM of 16, 24 and V equals 336, and their GCD is 4. GCD equals to 4. Find the value of V, or find the least possible value of V. Find the least possible value of V. So, what we do in this case is we are going to take the LCM of x and y. LCM of 16 and 24, we can look for it. So 16 and 24. Let's see what the LCM is going to be. So 2 because of 8 and 12. Another 2 because of 4 and 6. Another 2 because of 2 and 3. Another 2 because of 1 and 3. Then finally 3 because of 1 and 1. Therefore, the LCM of these two will be equal to 2 power 4 multiplied by 3. So this is 2 times 2 is 4 times 2, 8 times 2, 16 times 3. 16 times 3 is 48. So the LCM of these two numbers is 48. So we shall take our V. We shall take our V. I hope you can be able to see. Multiplied by the LCM of the two numbers which are known, which we have found to be 48, is equals to L times G. Our L is 336 times our G, which is 4. Then from there we can be able to calculate our V. Divide by 48, divide by 48. So our V will be equal to 336 divided by 48 from the calculator is going to give us 28. So the value of V is going to be 28. So that's how we work out a situation whereby the numbers are 3, we have the LCM of 2 of them and the GCD. To find the other number, this is the formula. Take the number multiplied by the LCM of the two numbers. The LCM of the two numbers which are available should be equal to the product of the LCM times the GCD. Now, I want us to generalize and summarize our topic by saying, when we come across a problem where the words greatest, largest, biggest, highest, or longest is used, always solve the GCD. Look for the GCD whenever you come across such words as greatest, largest, biggest, highest, or longest. Now, something else we can generalize is that when we come across a problem where the word is least, lowest, smallest, or shortest, that has always solved for LCM. Then the LCM can be used to know the time when two or more events occur at the same time. For example, there is the question which is usually asked about time. Like, for example, a bell rang at 10. When will it ring next? If the lessons are in intervals of 35 and 50 and so on and so forth. In such a situation, you are required to solve for LCM and not GCD. It's LCM required. So, that is the end of the lesson. Please go and do more practice about what we've just covered. And in case you find any problem, kindly use the comment section to ask, and I'll be glad to respond. Thank you so much for your time, for your cooperation, and let's meet in the next lesson. Kwaheri.